My name is Josh. I'm a solutions architect here at Pulumi. With me is Marina. Marina, if you want to introduce yourself to the folks again.
Yeah, for somebody who just joining, I'm partner solution architect at AWS, and I work with our ISV partners on technical aspect of relationship.
So, if you're going to follow along, there's some prerequisites that you'll need in order to complete this workshop. You'll need an AWS account. You can get a temporary account that will be good for the next 70 hours or so. That should be on the handouts tab. You'll need to supply the event engine hash ID, and that is the sticky thing in the chat. Starts with a 55. So if you go to Event Engine and you enter that hash ID, you'll be able to create a temporary AWS account. And if you don't have one already, you'll also need, of course, Pulumi, which is the tool that we'll be using today to do policy as code. You'll also need Python 3.9 or later. And I neglected to add to this slide, you'll probably want a Pulumi account as well. So just a little bit about Pulumi. So what is Pulumi? Pulumi is an infrastructure as code tool, although we'll be exploring its policy as code capabilities today. Essentially, what Pulumi, the things that make Pulumi unique in this space are that you are able to use real programming languages. Pulumi supports a pretty wide range of the most popular programming languages out there. We have support for Node, being TypeScript and JavaScript, Python, C#, Go. We have Java support that is in preview, and we also have a YAML option as well for folks who might prefer that. You can use Pulumi with a wide range of cloud backends, including, of course, AWS. But we also have like a Kubernetes provider that a lot of folks enjoy using, as well as integrations with a number of SaaS tools, such as Datadog, New Relic, GitHub, things like that. Pulumi is open source. Most of the stuff I'll be demoing today is available in the open source version. I will be sure to call out directly anything that is a paid option, and that'll be like the last part of this workshop. But Pulumi is open source and free to use. We also have a SaaS backend, what we call Pulumi service, and we'll get into some of those features a little bit later. We definitely encourage everyone who's following along to create an account at Pulumi. It is free for individuals. For individual use, it's free forever. So that will allow the Pulumi service will provide you with like state file management, secrets management, and unlimited updates. And it is free forever for individuals to use. If you would like to try out some of like all of our features, like the enterpriseiest of enterprise features, we call our business critical edition. After you create an account at Pulumi, you can create an organization and sign up for a 2-week free trial. That'll give you, again, all the features that the Pulumi service offers, and there is no credit card required. Okay, so what is policy as code? So some of you may remember that at one point the term DevSecOps became really popular. And so like if DevOps is largely about bringing like software development techniques into the operations space, DevSecOps and policy as code extends that to like security and compliance. So when we're doing policy as code, just like infrastructure as code, we're writing essentially software. And so we get all the benefits of describing our policies in software. Our policies are going to be repeatable. They're going to be versionable. It's going to be an automated process to check compliance. And so that's going to be really fast and accurate. In addition, when we are doing policy as code, there are 2 essential types of controls. There are preventative controls and detective controls. And preventative controls are policy checks that execute before we actually provision infrastructure. And the majority of what we're going to be showing today with Pulumi are preventative controls. In addition, there are detective controls. So like if any of you are familiar with AWS config, detective controls will verify infrastructure after it's already been provisioned. So you might create an S3 bucket, and then an AWS config rule will fire and check whether or not that bucket is in compliance with your organization's policies. And so each of these types of controls have different advantages. For preventative controls, you typically have to like execute those controls through a pipeline. And if you're doing everything through IAC, then that's going to catch the overwhelming majority of any non-compliant infrastructure. And so like these preventative controls will also give you fast feedback. However, detective controls, so you get slower feedback because you have to wait for the actual infrastructure to be provisioned before you can check it. However, it will check everything because even if you create those resources not through a normal process like your IAC pipeline and you create it through the console, that infrastructure will get checked. So let's move along. So examples of policies that we might want to create. If we are in a regulated field, let's say that we are working in healthcare, we may want to ensure that our infrastructure is only using HIPAA compliant services. And so we might want to write a policy for that. We might want to have policies around data loss prevention. So you might want to have backups, ensure that backups are turned on for RDS instances in your production environment. We might have rules around data security. So we might want to ensure that our S3 object, that we have encryption at rest turned on. For an example, we might want to create a rule for network security. So we don't want to allow SSH access from all IP addresses. We might want to have tagging rules that allow us to ensure that all of our resources have correct cost attribution. So this EC2 instance belongs to the accounting department, and this S3 bucket belongs to our analytics team, things like that. And likewise, we might want to have budget controls. So like we might want to ensure that in dev environments, we're not spinning up like really heavy EC2 instances and that we only allow that in our production environment. So Pulumi's policy as code tool is called CrossGuard. And some of its features are that you can write CrossGuard policy packs in either TypeScript or Python. You can also write them in JavaScript, so essentially Node or Python. You can use a policy pack against Pulumi infrastructure that is written in any language. So even if your infrastructure is written in, let's say, Golang, you can run any Pulumi policy pack against that infrastructure because it works off of this abstract Pulumi. It basically works off of like the JSON that's kind of generated behind the scenes rather than the running code itself. Pulumi individual policies have configurable enforcement levels, and we'll demonstrate all of those just pretty soon. Those enforcement levels, so they can be mandatory, which will fail the Pulumi command and prevent either the preview or update from going forward. They can be advisory, where they essentially print a warning, or they can be disabled altogether. Likewise, Pulumi policy packs have a shortcut that will allow you to set a default enforcement level for all policies in the policy pack. There are two types of policies that can be created. There are resource-based policies. So that would execute, for example, against a single S3 bucket. And those execute pre-deployment. So those are the preventative controls that we described. And that is the majority of what we'll be showing today, possibly the entirety. Actually, I think it's the entirety. In addition, there are stack validation rules, which will work against an entire Pulumi stack. And so like an example of Pulumi stack, you might create within a stack like a VPC, some EC2 instances, and a load balancer. And you would put all those things together in a Pulumi stack. The stack validation policy will validate all of the resources in the stack at once, but those generally happen after the deployment. So those are a little bit closer to like the detective rules that we described. So within Pulumi's policy as code solution, CrossGuard, the just pure open source will allow you to consume any existing policies that folks have written out there, because those are just essentially Python or Node libraries. You can author your own policies, and you can do self-managed policy integration. And we'll demonstrate that later. But essentially, when you run a Pulumi command, you can supply a list of policy packs that you want to run against that command, and so that will validate your infrastructure. In our page features, you can publish policies to the Pulumi service, and you can configure them via the UI within the Pulumi service. You can establish policy groups, so you can essentially say all production stacks have to comply with this production policy, and then those policies are enforced automatically when you run Pulumi commands by virtue of your stack being a part of the organization. That might sound a little esoteric, but we'll demo that later, and hopefully it will become clear. All right, so let's get started with some code. So folks who are following along at home, we are going to start with module 1. So the first thing we're going to do is create a directory. Okay, and we're going to change into it. We're going to make a couple of directories here. So we have an infra directory, which is where our Pulumi program, our infrastructure, is going to go. And we also have a policy directory, which is where we're going to be authoring our policies that work against that infrastructure. Okay, so now I'm going to change into the infra directory, and I'm going to initialize a new Pulumi program by entering the command Pulumi new AWS Python. And we're going to give this thing a name, workshop policy as code. Okay, so we're going to accept the defaults here. Stack name of dev already exists, unfortunately, because I forgot to delete that. So we'll make it dev2. That's fine. And if you were following along at home, when you get to this prompt, just pick the region that's closest to you. US East 1 should be fine. All right, so this is going to download and install some Python dependencies. And installing gRPC always takes just a little bit more time. Maybe while we're at it, I'm going to skip around just a little bit. And I'm going to initialize a Pulumi policy here. It's going to do its thing. And hopefully gRPC, yep, still installing. In the meanwhile, in the chat, how are folks doing?
I didn't see any questions. I posted the link to workshop, guys. If you like, it's very easy. Thank you, Sarah. It's very easy to copy paste comments from there. There is a button to copy it, and then you can keep the webinar on one side and like the instruction on another side. Hopefully you have 2 monitors. Yeah, let us know. We have time to help you.
I'm going to fire up Visual Studio Code. And I'm going to bump that font size up. I also need a how big do we need it? Actually, let me just do a double click there. All right, so that should be readable, I hope, from most folks. Let's see. Are we done installing? Nope.
Hope you don't have any issues, network issues again. You might want
No,
to
it's
consider
not.
changing internet provider.
Yeah. Yeah. Yes. My internet provider, which shall remain nameless, bit me at the worst possible time last workshop we did. So how are folks staying along? Did this actually finish installing for them? In the meanwhile, we can actually go on a little bit of a tour here. So within the infra directory, right, we have a Python virtual environment, and then we have our main.py. And this is where we're going to be defining our infrastructure. And in fact, let's give this thing, oops, change this import statement just a little bit. And then we're going to go, this needs to be AWS.S3 bucket, S3 it args, and we'll go ACL. That was public read, I believe.
So Jana is asking if there is lag. Let's try it. Josh, probably let's go through like why we have two folders and like what one folder for and what is second and like what we're doing. I'm not
Yeah.
sure if everybody catch it up.
Okay, so it looks like, okay. So we can explore these files. So this workshop assumes like some basic familiarity with Pulumi, but I can quickly go through what we have here. So this infra directory again is the Pulumi infrastructure code. That, and I have just spilled my water. It's always an adventure. So this is the Pulumi infrastructure code. This is the config file for our stack. That config file includes the region to which we are deploying. And I'm going to use my shirt to dry my water. Next, we have the Pulumi program configuration file, which gives the basics of like what our of our infrastructure code. Next, we have a standard pip requirements.txt file. So that includes the Pulumi SDK and the library Pulumi AWS, which gives us access to create AWS resources. So in the policy directory, so this is a policy pack. We again have a Python virtual environment. We then have the main function here. This is our basic. So Pulumi has created a kind of skeleton for us of an AWS policy pack, and we can explore that a little bit. So the first thing we do up here is we import the necessary objects from the Pulumi policy library. And then, so this is what allows us to create our rules in our policy pack. The next thing we have is our validator function. So this is a resource validation function, and it takes a standard signature of resource validation args and a function to call if we find that our resource is in violation of a policy. So the first thing we do in this function is we check to make sure that like we're actually looking at an S3 bucket. And we look at whether the user has defined an ACL. And then if that ACL happens to be public read or public read write, then we report the violation. And the level of violation that we report is dependent upon whether we configure the enforcement level to be mandatory, advised, or advisory. If it's disabled, then the violation won't be reported at all. And again, we'll demonstrate that shortly. So, and then once we define the validator function, we create the actual policy. The way we write this essentially and you can do this, you can define the validate function in line if you want. It's just a little bit easier to read if you separate the validator function from the policy. So this gives it a name, and then this name will print out when we violate the policy. And we give it a description. This description, I believe, displays in the Pulumi service UI if we want to configure it through there. And then finally, we create the policy pack, which is kind of like the library as a whole. This policy pack only has one policy in it, but we will be adding additional policies later as time goes on. So let's take a look here. We should be done pulling down. Yeah, we're all done pulling everything down. Cool. So coming back to the tutorial here, we are going to. Yeah. Okay. Let's see if we can get this policy to run. Where is? Okay. Cool. Nope, not the debug. Give me the terminal. There we go. Okay. So let's move to the infra directory. I'm going to add a dependency to requirements.txt in the infra directory. This is like a little bit of weirdness with how this works in Python, that you have to have the Pulumi policy library there before before you can run a policy in a Python program. It works a little bit differently in TypeScript. So I'm going to start my virtual environment, and then I'm going to install my requirements. Okay, cool. So those are now installed. And so let's take our infrastructure, which we have here. Okay, so we have the ACL set to public read. We have the policy here that says you can't set it to public read. And then we're going to run the Pulumi preview command. And we're going to set the policy pack flag to run the policy pack in our policy directory. And hopefully that makes sense to everyone. So let's give that a run and we'll see what happens. Okay, great. So the preview command failed, and we get in here with our policy violation that we have violated the policy rule that we set. Let's go into our policy, which we still have up here, and let's change this enforcement level to advisory. All right, and then let's run this again. All right. So now we see that this policy violation comes through as advisory. However, we can see that our command did not fail. There would be a, let's take a look, scroll up a little bit here. Right. So you can see it might be a little tough to see, but the arrow here in my prompt indicates that the previous command returned a non-zero exit code when I ran this with the mandatory flag. And so the command failed, and that would typically fail like our IAC deployment pipeline. But here we have a clean output. This returns 0. And so the command would succeed. If we want to, we can see what it looks like when we disable it altogether. So we'll run it one more time. Okay, and then we get no output whatsoever. It does say that it ran the policy pack, but we don't get any indication that we're in violation of a policy because our enforcement level is disabled. So while it's disabled, let's actually deploy it by running the Pulumi up command. Okay, so our infrastructure has been created. All right, that makes sense. So now let's change the enforcement level back to mandatory. And we'll run Pulumi up again. So what do we think is going to happen here? Well, it's definitely going to succeed because I didn't tell it what policy pack to do. Okay, so now we're going to run the Pulumi off command again, but this time we're going to pass it the policy pack path. So this is all right, run an update, which there will be no changes in because we haven't changed our infrastructure code at all. We've only changed the policy. And so here we can see that our policy pack still runs against infrastructure that has already been deployed. And this is a very good thing because this will allow us to introduce policies in our organization after infrastructure has already been deployed, because the ultimate goal of our policies is that everything is in compliance. So in a production scenario, you might want to start to introduce your policies as advisory first, and then give your infrastructure and application teams a chance to catch up with those policies. And then you might eventually make them mandatory. Okay, so scrolling over to my notes. I think we've covered, so that pretty much covers all of the material in the first module. So now we're going to move on to the second module, and in this module, we're going to be authoring some policy or two, and we're going to see like what that experience is like. So let's write a new resource policy here. We're going to add the force destroy flag to, so we're going to go back to our infrastructure here, and we're going to add the force destroy equals true flag. Okay, and what this does is this will kill all of the objects in the bucket along with the bucket when you delete it. And so this is obviously not something you would want to do if there is data you want to keep. So let's add a function to our policy that ensures that that this flag cannot be set. So we're going to define a function. We're going to go S3 no force destroy validator. And then, as I mentioned earlier, we have the signature of args, which is resource validation args, and then report violation, which is the function that we'll call if we are in a violation of the function. I forgot my colon there. Report violation. Okay, great. Okay, so the first thing we're going to check is the resource type. So all resources get passed through all resource validation functions. So there are some cases where you might want to use a single validator against multiple resources. I can't think of any off the top of my head right now, but I could if I had more time. So we can do args.resource type equal or is not equal to AWS S3 bucket. And this identifier is like, you'll get the pattern of these. If you really want to do a deep dive, within the part of the internal magic that allows Pulumi to work with multiple languages is that we have an internal schema to our providers, like the AWS provider. And this is just the identifier within that schema for a bucket. So buckets have a resource type. So if we are not looking at an S3 bucket, we want to quit. We're not interested in validating this any further. So, and now we have to say if force destroy is not in args.props, and args.props will be, and then we're going back to the infrastructure here. Args.props will give us, for example, the ACL and the force destroy value. If force destroy is not specified, we're good. We don't need to validate any further. You may be wondering again why we're using lowercase f capital D destroy instead of force underscore destroy as it is in our Python program. Again, this is because we are using the identifier that's in the Pulumi schema. Again, the identifiers in the schema follow a pretty regular pattern that should be pretty easy to pick up. But this is kind of part of the magic that allows us to use a policy pack written in any language against infrastructure written in any other language. So if force destroy has not been set, then we can return. Okay. And now, finally, if args.props here, if force destroy is set to true, now we're going to call report violation. And we'll say force destroy must be disabled for S3 buckets. Alternatively, so we could throw additional conditions on here. We could maybe look at the tags and say if the tag is if the tag is not equal, if like environment, if we had an environment tag that is not equal to production, we might want to allow force destroy, or we might say if the tag environment must be set to the value dev. There's a lot of different ways we could slice and dice that, but for now we're just going to do a simple rule. Okay, so the next thing we need to do is we need to create the actual resource validation policy object now that we've written our validator function. And actually, let me take a moment right now to pause. How are folks getting along in the chat? Is this clear to everybody?
We have one question from Daniel.
So Daniel asks, do you have advice or best practices for writing tests to test your policies? So you would be able to export these functions using, whatever, either using the in Python, you could import the module. In TypeScript, you could export these. But as you can see here, like, you would be able to test these just by passing through resource validation args and report violation and writing unit tests just the same as you would with any other application code. You wouldn't really need much special stuff beyond that. If you wanted to write integration tests against that, you certainly could do that. I'm going to mention this a little bit more later, but Pulumi has a library called AWS Guard that does have integration tests that test like full Pulumi programs against this. But for the purposes of authoring a policy pack, that's probably not necessary. You will probably be able to do this just via simple unit testing. If that answered your question, could you throw me a thumbs up? And also, if anyone else has questions, please do let me know. How are folks following along? Is everything clear so far? All right. Well, cool. All right. I answered Daniel's question. And again, if anyone else has any questions or you need me to go over anything, just say the word and I'll be happy to do that. But as long as the chat is clear, I'm going to move along here. So let's create our actual rule, which we'll call S3 no force destroy. And we're going to call the resource validation policy constructor. Okay, so we're going to give it a name. And this is just an identifier that's going to spit out. So, for the prefabricated rule that we ran earlier, we have this S3 no public read. That's exactly what's going to spit out the command line. So we're going to go S3 no force destroy. Cool. Okay, let's give it a description. And we can say prohibits force destroy on S3 buckets. Cool. And then we need to say what the validation function is. Validate equals, and that's going to be the function that we defined above. And then finally, we need to add it to the policy pack. Okay. One more thing I'd like to show is that, so I mentioned that this enforcement level here at the policy pack level, that enforcement level it becomes the default for all policies. However, you can override this at an individual policy level. So let's make this one enforcement level equals. Yeah, actually, I want to just copy this line. Make this one advisory. Okay. So we have saved this, and back in our infrastructure file, we note that force destroy is set to true. So let's see what happens when we run Pulumi preview against our policy pack. Okay, and just as we expect, we're still in violation of this no public read policy. And our new policy indicates that we are in violation at an advisory level. And hopefully if we change this to be false, which is the default. We could also omit it and we would have the same effect. And we run this again. We only see the previous mandatory violation for our ACL. And so we are now in compliance with the new policy we've written. And it's really that simple. So I'm going to take another pause for questions. But if there are no questions, we can move on to demoing some of the enterprise features. How are folks getting along in the chat? Is there anything else I could explain? Anything else that was unclear? You want me to go over anything? You want me to change anything in the code? Happy to do whatever I can to illustrate the utility of Pulumi policy packs. And Marina has just posted a link to some of the documentation. That's our CrossGuard guide in the Pulumi docs. All right, I'm going to give it last call for questions for the moment. We have a question from Raul. Would this also work for Kate's provider resources? Yes. Yes. So any Pulumi, yes, and for any third-party provider, yes. There's nothing that's AWS specific about policy packs. We're just demonstrating them with AWS resources. If you were writing a Kubernetes policy, you would be checking against instead of, let's say, you would be checking against instead of AWS S3 bucket, you would be doing, I think it would be like Kubernetes V1 blah 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 blah. Maybe you'd be checking deployment or replica sets. And then you would likewise be able to go through the properties of your replica set to find like, oh, like, you know, you're not allowed to deploy, you know, a single replica in a replica set. And it will work with it should work with any other provider in the Pulumi ecosystem. Any other questions? Okay.
Looks good. Let's move on then. Guys, you can post any question anytime. And we have more from Andrew.
So is AWS Guard updated to match changes in AWS Trusted Advisor or SCP guardrails? So the answer is not at present. AWS Guard is still in preview. I think it's at like 0.4. However, if you want to submit GitHub issues to like get those things in there, that's stuff that we would love to provide for you. So and there's no like automated update, but we our intent is to eventually make AWS Guard like a pretty complete set of rules that should help you ensure that your infrastructure is in good shape before it goes to production. Okay, so at this point, I am going to bring over the Pulumi app. Okay, and I will. Okay, so this is the Pulumi service. In the Pulumi service, you get a list of your stacks. You can see here. So the way that if you want to do the 2-week free trial and you sign up for your Pulumi account, you'll have an individual one. So that's my individual. And then if you want to sign up for a trial, you can go create organization, and then that will take you to the trial initialization page. In the Pulumi app, we get a list of stacks. We get you can see like the update history. You can see what resources are in your stack. You get convenient links to open those resources in the AWS console if you want to inspect them. You get a history of all the updates that you did, along with the output from the command line. So this kind of provides visibility when you're working in a team context as to like who changed what and when. Always very important when you're dealing with infrastructure. And you can see that even our attempted update, which failed our policy, is also included in here. So essentially, all of the output of the command line is also available within the Pulumi service. So what I'm going to do next is we are going to make a new directory. And what we're going to do is we're going to leverage the Pulumi AWS Guard library. And I'm going to go Pulumi. Give me 1 second. Let me make sure I type this command right. Okay, so the first thing I'm going to do is set my default org, which is to my personal. It's an organization, but I'm the only one in it. And we're going to go Pulumi policy new. And just like when you run Pulumi new, you're going to be able to choose from a list of existing templates. And so what we're going to do here is we're going to select AWS Guard TypeScript. As you can see, we have about a dozen or so different templates for you to start writing your policies from. But AWS Guard is going to bring in the Pulumi AWS Guard library, which has, I think, something like it's got dozens of rules at least. So let's see what that generated. Let's fire up Visual Studio Code. So we don't need to do that. We can reuse the existing window. I'm going to close all of the previous stuff. And so we're going to go here and let's see what it created. Okay. So so we're jumping languages a little bit, and I hope folks are able to follow. If anything is unclear, please just call it out in the chat, and we'll try and get that answered for you. So we're pulling in this AWS Guard class, which is so what we're doing here is a little bit different. Rather than authoring a policy pack, we're actually consuming one. And so the AWS Guard library in TypeScript is a published Pulumi pack that's available for you to consume. And so within AWS Guard, you have a whole bunch of rules. And you can see here, we have, like, for example, ACM certificate expiration. And then for each of these rules, we can configure the enforcement level for each rule. And so like we might want to disable, for example, ACM certificate expiration. So essentially what we're doing here is like we're taking an existing set of policies and we are consuming them and configuring them the way we want. And someone in the chat is getting an error when executing. Okay. If
I ask it to post me an error.
Okay, great. So we'll try and get you helped out as soon as possible. So what we're going to do now is we're going to take this policy. So imagine in your mind that we're going to look through all of these rules, and we're going to either make them warnings or disable them as we see fit. Okay, and then we're going to move to the directory, and then we're going to go the command text so I don't have to hunt peck here. And you will probably not have to do this, but I do because I've published an identically named policy many times. So we're going to version 0.0.4. You at home, if you're following along, will not have to fill this in unless you've already published a policy pack by this name. But my organization has a little bit of leftover state from previous times I've run through this demo. So now let's publish our policy. Okay, great. So you can see the Pulumi command line gives us a nice handy permalink, but I'm just going to jump to the service. And if you go under policies, you can see that this is the policy pack that we have published. We can click into it and see a nice display of all of the rules and their enforcement level and their description. Just like you might remember earlier when we were authoring our own policy pack, these are the attributes that we were defining, right? Because we gave it a name, we gave it an enforcement level, and we gave it a description. So this by itself is not going to do anything. It's not going to validate any of our stacks, our Pulumi infrastructure. In order to do that, we need to go to the policy groups. And so, what policy groups do are they allow us to automatically enforce a policy pack across a group of Pulumi stacks. And when you enable the business critical features, if you sign up for that 2-week free trial, you will get a default policy group. And so the default policy group will, by default, include all of your stacks. So you don't need to do anything extra to ensure that your stacks are covered by whatever policies you associate with the default policy group. Hopefully that makes sense. Someone give me a thumbs up in the chat if that did make sense to them. I can only assume that silence means that it was perfectly understandable. So within our default policy group, there we go. There's all right. There's a thumb up. So what we're going to do is we're going to add the policy pack that we just published to this policy group. Pulumi AWS guard, and then we're going to select a version. So in a more production scenario, you will be able to safely roll out these policy versions and not have them like be automatically applied everywhere. So you can sort of like, if you want to canary deploy new policy packs and only apply them to like 1 or 2 stacks just to make sure that they're not going to cause all hell to break loose, you can do that. You can roll these things out in a very controlled way. So we're going to select version 4, which is the one that we just published. And then when we do that, you'll notice that we can configure each of these individual rules in this UI. Now, we didn't cover this because we didn't author them because it's a little bit tricky to author them within this workshop context. But every individual policy rule, you can define a configuration schema. And that configuration schema allows you to essentially pass parameters to the rule. So you might say, for example, this is for IAM access keys that you can set the enforcement level, which we've already covered. But you can also set this parameter that says the max key age must be 90, and we might change that to say 30. The details of this are in the Pulumi docs, but it's a little bit more of an advanced feature. And you might want to wait a little while until you get comfortable using policy packs before you add the configuration schemas to each rule. But you can see that we can have sort of numerical parameters in it. We can have Boolean stuff. So this is a rule that controls which API gateway types we allow. Let's see if there's anything else interesting in here. Looks pretty much like so for encrypted volumes, you can say that they must be encrypted with a particular KMS key. Looks like we can create lists of node types that are allowed in our Redshift clusters, things like that. So let's enable this policy pack. And then you can see that within the UI, we also get a nice list of the configuration. And so let's see what happens. So what we're going to do is we're going to go back to our infrastructure. And we're going to change directories back there. And we're just going to run Pulumi preview. And I'm going to check my configuration one last time. So we did. All right. So yes. So we added that. Good. So we're going to run the Pulumi preview command now. And let's see what happens. And you can see, so we added this policy pack to the default the default policy group. And so that means that it will apply by default to every stack in our organization. And so it is running right now. You can see that it downloaded and installed the policy pack that we just published and automatically ran it for compliance. And so this is like we no longer have to include this -- policy pack flag to ensure that the policies are applied the way we would like. So that is the end of the demo of the business critical features with Pulumi policies. So at this point, I would like to know, do folks have any questions? Is there anything else you'd like to see me demonstrate? And it is quiet in the chat at the moment. Any other questions folks would like to see answered about Pulumi policy packs? Another question. Is the only way to enforce a policy pack by using the Pulumi service? If you don't use the Pulumi service, you have to trust the developers to use the policy pack, right? That is essentially correct. There are other ways around that. If your infrastructure team controls the pipeline, you might be able to define the command so that it forces you to use the policy pack. But that is yes, and that's essentially the value prop of using the Pulumi service is that you get that enforcement kind of automatically without having to manage the policy pack command itself. Are there any managed Pulumi policy packs for SOC or ISO? Not at present. If that's something you'd like to see, please provide us some feedback. You could do that via GitHub issues. That would be one way to do it. Another way is to reach out in the Pulumi community Slack, and that will definitely get the eyeballs of some Pulumi employees. All right. Does anyone else have additional questions? Please do not be shy because we are finished a little bit early. Although I don't think if I let everyone go early, anyone would necessarily complain. But happy to stick around and answer questions. Okay. So, if you would like to continue your journey with Pulumi, we have another question in the Q&A. When the policy is applied, does it apply to pre-deployed infrastructure or only infrastructure deployed after the policy is applied? That's a great question. It applies to infrastructure, all infrastructure, whether it's been deployed or whether we're planning to deploy it. And that way, like we can introduce policies after the fact, because in a lot of orgs, as you may have experienced, there's maybe not a lot of policy around cloud usage. And then hopefully before an incident happens, we realize that we need to put some controls around these things. And so you can apply policies after the fact, and they will apply to infrastructure that's already been deployed. The Pulumi policies will not necessarily remediate it, but it will essentially stop your infrastructure pipeline from proceeding until the infrastructure is remediated.
I have one more in the chat.
Can we use Pulumi to create an STS resource? Token service? Jose, if you could explain a little bit more. I'm not sure what there is presumably, let me check here in the registry. I would assume so. I can't think offhand of which resources you might need. Let me look at the AWS Classic documentation. There's not an STS namespace per se. Which resource? All right. So if you get back to us in the chat, I'll continue my spiel on continuing your journey, and just let me know if there's anything we do to clarify that answer. So we have workshops at the Pulumi website. Most of the workshops we give have a self-guided component. You can check those out. So you can go to pulumi.com/resources. Likewise, we have, if you go to pulumi.awsworkshop.io, you can view the self-guided version of this workshop in addition to a lot of other material we have out there, including stuff that'll get you started writing infrastructure in Pulumi. We also have documentation on all the CrossGuard core concepts that will help you author your own policy packs. There is a lovely examples repo that will give you a whole bunch of full Pulumi programs that spin up infrastructure that they'll demonstrate the use of all the various services. We also have a new thing. There are these Pulumi templates. They also live in the examples repository. But if you go to, I think it's pulumi.com/templates, they're like a little bit more fleshed out. So we today demonstrated we just went Pulumi new AWS Python, which creates only a single S3 resource. But we have a template that will do, for example, an entire static site. And there's a whole bunch of templates out there They should cover all of the major architectures that you might want to try. We have one for container, one for serverless, static sites, probably a few others that I can't remember off the top of my head. But go check it out. Those templates are like really, really useful, and I think are really going to be great. Maybe if you're coming like from the policy side and then want to see a little bit more of like the infrastructure creation abilities. And then finally, we have AWS Guard, which is a kind of prefabricated list of AWS rules. And so that's what we demonstrated when we pushed our policy pack to the Pulumi service. However, you can also use AWS Guard in an open source way if you just supply the -- policy pack flag to the AWS Guard policy pack that we created. So a few more questions in the chat have come through, and let's take a look at those. So Eric says, I believe I saw there was an integration with Open Policy Agent. How does this relate to the setup here? So I have not used the OPA integration. I think at this point it's fairly rudimentary, but there is some interop between Pulumi and OPA, but I'm not sure that the full complement of I forget the name of the OPA like declaration library. If someone wants to throw that in the chat, I will be happy to mention that. But I don't think we support all of the constructs in OPA, but some of them are. If you want to give that a try and give us some feedback on it, that would be stupendous. Daniel asks, follow up from the previous question: is there a way to enforce policies, new resources as mandatory, but existing resources as advisory? Good question. If you want to join the Pulumi Slack or DM me on Twitter, my handle is at the top of this slide. I will be happy to run that for you. I don't know offhand if when a resource is passed through to that validator function, if you're able to tell whether it is new or existing. You might though, maybe. That's a great question, and maybe I'll add that to the tutorial if I can figure that one out. How does CrossGuard compare to Sentinel? So that's a great question. For those that don't know, Sentinel is HashiCorp's policies code tool. To my knowledge, I believe Sentinel only works with HCL configurations. Likewise, Pulumi CrossGuard will only work against Pulumi programs. And Eric noted that Rego is the policy language for OPA, which is, thank you, that's the one that I could not remember. Okay, so any more questions from anyone? If you do think of any questions afterwards, by the way, please feel free to DM me on Twitter or mention me on Twitter. My handle is again at the top of the slide. It's my name, Josh Kadroff. You can also find me on the Pulumi community Slack. Please, if you're going to ask a question in the community Slack, do ask that in a public channel so that other folks both have an opportunity to answer and also not only to answer, but also to not only to answer, but so that other folks maybe with the same question are able to view it. Okay. Well, if that's if there are no further questions, I want to thank everyone for joining us today. Really appreciate you spending some time with us. And we hope you have a great time using Pulumi policy as code.